I am Nathan Barnett, and I'm hoping today to present a little bit of our experience, pitfalls, things we've learned, things that we loved with Clojure, running it in production. We use Clojurescript in the web browser. We have a full Clojure backend. We interface with all sorts of other cloud systems, so maybe we can help prevent some of the missteps that we made with other people, and also show you unexpected good things that we found in also just, general Clojure love. So let's go. All right, so first, before I get into the design of our system, I think that you sort of have to know what our system does, and to get to what our system does, we have to sort of go with the why, because frankly, almost everything people build is for a reason why, and the what just sort of flows from that. So let's begin with an experiment. If you have kids, know kids, have seen kids, imagine you put a child down, a 2-year-old, in front of Dora the Explorer. And now we're going to add something. We're going to add this. If you have kids, you know what's coming on this next slide. This is what's coming on the next slide. And this is actually my daughter was 2 at the time. This is a real picture of what happened when Dora the Explorer froze up at our house. And so a company was born. This is the why. She actually tells her friends that her daddy is fixing YouTube, because how else do you explain it to her? She's now 5 though, and it's been 3 years of sort of solving this. But honestly, this is sort of how we all feel inside when video on the internet fails. We're all wanting to kind of scream and cry. We've just sort of built on these layers of, I guess, maturity, we'll call it, where we don't do that anymore. And so our system is designed to make video no longer buffer, no longer fail, no longer show sort of the grainy bit rates. And basically, we can never make the current situation worse. So always better, never worse. And so everything is designed with that in mind. We can't have an outage because of some system on our end being down. We can't have an outage because our code doesn't work in the browser and screws up the video playback. So let's talk about why Clojure. Well, a couple of reasons. I actually learned Lisp when I was in high school. Did the whole Eliza sort of psychologist programming thing. If you've ever seen that, it was kind of like a bot, just way worse. If it didn't understand what you said, it would just pluck something from the history and say, oh, you said you liked hockey earlier, so tell me more about hockey or something, But I learned that in high school, and then it was sort of a unique thing in that it was one of those languages that sort of stuck with me. It always seemed to have this place around academia and early AI. And so then when Clojure sort of came out and brought Lisp and meshed it with all of the libraries from Java, and then there was Clojurescript as well, so that we could kind of program in one language, both client and server side, we just figured we'd give it a shot. And so this was in like late 2013, so this was early on the Clojurescript side. We've had lots of sort of bumps in the road that we've solved, and I think they're solved now in better ways, but what we have works, so we've just sort of lived with them. The second thing that was important with Clojure is the REPL, and that's so that you get that sort of instant feedback. You can kind of play around with it. You can try and solve the problems interactively, and that's been very helpful. And of course, we all know this because we're here for Clojure, but when I get to the team piece, these are the types of things that are important to explain to a person why they have to learn this weird new syntax with lots of parentheses. So it's important to remember these are the kinds of things besides just something about the language that was nice. The functional thing helps sort of reduce bugs. You can keep all of your state in one area, which is very helpful for debugging and testing. In our system in particular, we have a large scale of clients, so everyone watching video at all of our customer websites, all connected to us simultaneously, sending lots of data. And there's some other pieces that we've created where the clients can interconnect with each other. And so the STM was very important for that because it sort of abstracted away a lot of the kind of race conditions that are sort of very common in that multi-threaded programming. Now we found new, more complicated and better race conditions that we created ourselves. And but at least some of them were taken care of. Also, our system is very much written like a client application, but in JavaScript. So being able to avoid JavaScript's lack of threading with core async, I mean, it still isn't real threading, but at least all your logic is in the same place. Avoiding that callback sort of situation was also very helpful. I've always liked Emacs, so why not? And maybe it's fun, so we'll see. So next I'll talk about sort of how the system works. So we have all of the clients that are watching video in various devices, and our solution initially targeted web browsers. So you can imagine these are people, mobile browser, desktop browser, iPad browser, etc. And those are all running Clojurescript. We basically keep a WebSocket connection open, and it sends EDN messages to the cloud on the right side. And we sort of designed the whole system to use this sort of messaging architecture so that if you design for messages, you're already inherently expecting that you might not get a response, or the response might take a long time. And that helps sort of build a scenario where you're not like making an API call, and if it doesn't come back, video doesn't play back. Again, we can never make the situation worse, or customers will not be happy with us because we're supposed to be making the situation better. Last year, I came to Clojure West, and I saw a particularly interesting talk that I think if this type of thing interests you, would be good for people to watch. And it was the Web Development is Distributed Systems Programming by Michaela Patella. Hopefully I said that right. I'm terrible with pronunciation of names. And she talked about how if you just relabel yourself, even as a web developer on the client side or on the server side, as a distributed systems programmer, not only does that help you from a salary and hireability standpoint, but it helps you rethink what you're actually doing. And I think that that's a very valuable sort of thought to keep in mind, is that each piece in our system is connected through messaging, and they just have different limitations. So in the browser, there's certain limitations. On the server, there's certain limitations. But essentially, it's distributed systems that talk to each other. So what is in the cloud? Let's see. Well, it's turtles all the way down. It's actually not turtles. It's all messages. We use agents, Aleph, core async, and lots of messaging. And basically, internally on the server, I'll get into some of the use cases with why we're using different sort of message systems. But it's all sort of messaging. It's all sort of asynchronous all throughout. And then we also talk with some various cloud systems through messaging. We use like Google's Dataflow, which does our big data processing for us for a lot of these messaging use cases. All right, so on the development side, let's talk about what not only me, but our development team now loved about Clojure, and they really like that REPL-based development. They like that instant feedback. Early on with Clojurescript, that was very difficult, and so there was this sort of shock when they went from the server side to the client side. My understanding is that's much better now. We've unfortunately done some things that we would have to go fix a bunch of old code to actually make that work the way we want it. So we do use the REPL base for Clojurescript a little bit. Mostly we have it sort of compiling and then we're hitting refresh. So it's not all instantaneous like we would like it to be. They also love the access to the Java library. So basically, if there's ever a library that is not in Clojure, you can find a Java library for it. And so worst case, you can always kind of default to that. So you're not in a scenario where whatever you want to interface with or whatever you want to do, like no one's ever done that before. The Java ecosystem is giant. I mean, there's pretty much solutions for everything. I saw some talks yesterday and earlier today where people are constantly talking about new libraries that I had never heard of that have been around a long time. So a lot of stuff is solved for you. New database comes out, there's probably going to be a Java library for it. If you hear some technique for solving differential equations, there's probably a Java library for it, which is really, really useful in terms of productivity so that we can just focus on what we're doing and not creating sort of custom libraries for things that are already solved somewhere else. They also, they really liked continuous integration, although that's not specific to Clojure. that was a piece that we built in very early on with this process, where we actually use the great Circle CI. Continuous integration, so every commit, every build is being run through continuous integration. It notifies them of the any sort of issues, of course. Now, there were some challenges with continuous integration. Again, especially on the Clojurescript side, it's gotten tremendously better. But even on the Clojure side, one of the things that has been somewhat challenging is that the libraries for testing and what has been sort of, I don't know, in vogue at the time has changed. And so we have stuff in the default Clojure testing library. We have some Midgy testing. We have Karma testing for the JavaScript side. It's been one of those unfortunate things in that very early on in Clojure, the testing itself was still being figured out what the best way to do it was, what made sense, what didn't. And so one of the things that we've done recently is that if Clojure core has the solution, that is what we use, because the core has been very good at being stable, kind of follows our philosophy of only better. New updates only make it better. They don't really change a bunch of surface area to where things break. The devs, our developers also like that basically there's kind of two things in Clojure. I know this is a simplification, but things are either a hash or a sequence. So data types, et cetera, it's either a hash or a sequence, or a hash of sequences, or a sequence of hashes. But you don't have to keep learning all these kind of bizarre data types. You can just sort of print out the data type and you'll see what's in it. There's not really any surprises there. I know that's super core of the language, but it also sort of enters into your thinking when you're building in Clojure. Everything starts looking like a hash or sequence. So this is one of those things where I'm one of these people that doesn't like to decide what clothes I wear each day, so I have a sequence of clothing, and new, fresh clothes go on the back end, and then I just keep pulling them off the stack on the other side. That's maybe too much information, but that's what I'm here for. And then they really like the threading for JavaScript, so the sort of being able to use the Go loops to help kind of I don't want to say cover over, but not make you have so much cognitive load on the JavaScript side with all of the callbacks, because essentially all the logic kind of flows in order with the Go loops. You're sort of, you're seeing it as pulling things out of a queue, essentially, versus the callback scenario. I know JavaScript has made lots of advances in that space, but we didn't have to learn them, so that's good. But we did have to learn how to figure out the core async stack traces in JavaScript, which were pretty rough for a while. And then Emacs, I loved Emacs. We'll find out about the rest of the team. They learned that the parentheses that initially sort of caused people problems after you just accept them, that it's actually nice because it's very clear where things start and stop, and you don't have confusion. It's all of the sort of notation around the code is the same. And that they learned to really like that. We also learned that pretty much all the bugs are in the stateful part, which is one of those things that I think is important to recognize. So that in Clojure, mostly you're trying to keep all of the functional stuff in one place that you can test very well, and the stateful stuff sort of at the edges in a separate area that you can sort of test the state piece separate from the functional piece, and be certain that the functional piece is working, and then the bugs are in the stateful part, and that's been pretty much our experience, is that they're almost all in the stateful part. Also, they liked it at the REPL. If you're testing the functional part and you are trying to figure out whether your function does what it's supposed to do, you can run it there at the REPL, and if it now does what you want it to do, or if it failed to do what you wanted to do and you had to recompile it, now you can just copy and paste that testing you were doing at the REPL into your unit tests. It's actually a really great way to at least ensure you don't have regressions, sort of document the sort of ways it could have gone wrong in the past. It just makes that very simple, because you're essentially writing tests as part of your coding. And then the last one, which I've seen lots of people on Emacs here. Again, I love Emacs. For developers who don't know Emacs coming in, making them learn Emacs is probably not the right way to go. We found that having them use cursive is actually a much simpler, kinder way to get them into Clojure. And fortunately or unfortunately, they usually stay in cursive. It's one of those things where I think those of us that use Emacs are kind of like, it just feels very magical when you're using Emacs. It's just, your brain's in tune with it. But I think it just looks very confusing to people who don't know Emacs. And it's best not to force that on them, because if you're going to try and teach them Clojure, it's better not to try and make them learn too many things, so that at least they're not hating Emacs and thinking that Clojure is Emacs, So here's some of the things we loathed. We've been in Clojure for a long time, so we have a whole litany of basically abandoned libraries. The good part about abandoned libraries is that if they were working in production, they're still working in production. But there has been sort of this trail of frameworks and recommended ways of doing things that have all sort of died off. I mean, we still have some internal admin tools that run on the first pedestal, so not whichever one they're talking about now. I don't even want to go see it. Not because I don't think it's great, but because our whole team learned the first pedestal, which we thought was awesome, and it went away. And so, that's a struggle a bit, is that there's not, the libraries just sort of get left behind. Also, choice can be bad, in the sense of, one example I was talking with some people here about is that if you want to do logging, like you just want to log stuff in Clojure, and there's like 4 or 5 libraries, if you pick the wrong one and then it later gets abandoned, like you made the wrong choice. So you don't always want choice around things that like everybody's going to be doing. I'm not saying any one's better than the other. I'm just saying that, sort of from a longer term standpoint, having all the choice allows you to more easily fall into the pitfalls of the abandoned libraries. Debugging, it's getting a lot better. It can be difficult to wrap your head around initially from the developer standpoint of the stack traces. They're complicated. I know we've had many instances where when you have macros, it can kind of confuse the stack trace if someone's not taking real good care when they write those macros to try and do something to help make those errors more sort of presentable. The evolving too fast is kind of like with the abandoned libraries. I mean, I know it sounds bad because you want things to evolve fast, but it does leave people behind in again, production that gets hard. I have on here, diff and merge with parens makes you sad. Because a lot of times when you're checking in new code, if you have the parens and it'll like add an extra one to the bottom, if you ignore white space, then it'll maybe do, sort of 2 different lines it's adding, and it makes it very easy to have these sort of git commits that look very strange. It's not just like the line of code you wrote. There's like extra parens that get pushed into other places, and that doesn't make it as clear when you're kind of doing a git diff against the code. Universally, everyone who didn't know Emacs on our team hates Emacs. So they don't share my sort of love of it. I mean, they like watching people use Emacs. They just don't want to use it themselves. Advanced compile for Clojurescript. If you've ever used Clojurescript, advanced compile is just like it's just a sort of field full of mines. We've gotten to a place now where we've made all these sort of changes to make it not so thorny. I watched a talk yesterday about how to generate the externs. We've just used line externs, if anyone's familiar with it. It basically just generates an externs file. It's not optimized externs. It's just you won't shoot yourself in the foot with those externs in that file. And we've just gone with that because we'd rather not break stuff than overly worry about the optimization at this point. All right, I'm going to go into the operational standpoint, from actually operating these things. So some of the things we love. Stability, basically the stuff runs and we don't really have problems. Part of that's our configuration, but Clojure itself is very stable once you've worked out the issues. There aren't as many race conditions, although they do pop up, but you tend to find those fairly quickly. There's not a lot of bugs that sort of just hide out for a long amount of time, although I will cover one in a little bit here that was particularly vexing. And so that part's really great. And even those old libraries, like I was saying, they continue to run, work perfectly fine. It's just that if you now need a new feature, for example, if it was interfacing with a cloud service, and they added some new features to the cloud service, and now the library that you were using is abandoned. You now have to like switch libraries completely to one that now supports those extra features, and that's kind of a pain. But if you don't ever need that, the old code works perfectly fine. A little bit later on, I'll show a lot of the libraries we use, and I'll mention them for two reasons. One is to kind of like thank the community for providing all those libraries, because it's really a system that depends on a lot of work from everybody on all sides. But also a lot of those libraries, if you're newer to Clojure, you'll probably never have heard of and never will. And then also in operations, they really like the performance. I mean, the multi-threading, the STM, the software transactional memory works really, really, really well. As long as you know what the contracts are on those types of things with atoms and agents, it all works really great if that's part of your use case. And then we really like Aleph. We've used it for a long time. I don't know if Zach Tellman's in here, but he's probably not. He knows all this stuff. Aleph is really great because it allows you to sort of control. It's like a core async with more controls over threading, and you can have the way we used it is we have a fixed number of worker threads based on the computers that the code is running on, and our system is built in a way that messages can kind of disappear and not be handled, and we don't want that to happen, but it doesn't actually break anything on the video playback side. And so it supports lots of those things so that if you had some crazy client, which can happen in the web world, they won't take down your whole system. So it has lots of nice controls over throttling, fixed worker threads, and Zach fixes things really quick. I came last year with a problem. I went to his unsession where we were all drinking beers. I mentioned it to him. He said, put in a pull request. When I got back to the room that night, I put in the pull request so I wouldn't forget. And then like an hour later, it was fixed and he had released a new version. So he cares about these things. So if you see him, give him a high five for me. He's awesome. Some things that we learned. nREPL is your friend. Sometimes when stuff goes wrong in production, we actually have a REPL that is available on localhost on the boxes, so we can kind of connect in remotely and connect up to a REPL of a live production box. And that is super useful when you're trying to debug things, because sometimes what is breaking only occurs in production, and being able to sort of dump out certain variables, see what's going in, count things that you expect to have a low number of items and see whether they have a high number of items. Those types of things are really great. And they help work around some of the other debugging challenges that exist in Clojure. We also learned don't upgrade the libraries for no reason. The semantic versioning, not everyone follows that, and so sometimes you upgrade what is supposed to be a minor release and it will break things, so we don't upgrade them unless things are broken, which is also, I mean, it's something we learned, but then it's also not good because you'd like to keep up on security things. So there's this sort of weird mix where you have to approach upgrades with a lot of caution on the libraries, and they're upgrading very rapidly. Sometimes we're 2 and 3 and 4 minor versions behind. We also learned that the best way to sort of handle these processes in production is to, we use Monit to kind of like monitor the process. It'll check whether the server's still live. It can check things like, is it using too much memory? Is it using too much CPU for too long of a period of time? And we'll auto restart the process. That works really well to avoid scenarios where like the garbage collection is not kind of doing what you would expect and it starts eating up too much memory. You can sort of put hard limits and set it to restart. The other thing we learned is that to have it crash on out of memory exceptions instead of just like throwing an exception in the code, because pretty much if the process runs out of memory, we'd rather just die and restart than to just throw an exception internally. And that when you do that, to not have the heap dump go to disk, because sometimes it will fill the entire disk and then things will not restart. These are just little things we've learned from having them happen. And we also learned, memory usage is fairly high. I think that's kind of a common thing with Java. It's just a thing that we know and we deal with. All right, so some of the stuff that we did not have fun with were the memory leaks, which were generally race conditions. This is not particular to Clojure itself. It's actually our code that was bad that did these things. But it gets really hard to track these down. Essentially we would end up kind of remoting in and hooking up JVisual VM and then trying to watch whatever native objects, that all this Clojure stuff translates to, and figuring out what's going on and where these memory leaks are. And it ends up being kind of difficult. The other thing, there are sometimes obscure bugs, which I'm covering on the next slide. Dependency conflicts. Someone actually said, was talking to me earlier, said, oh, did you not come from Java? This is like a thing we know about in Java. Yeah, I mean, I did Java a long time ago, but the dependency conflicts are very insidious, even to where it'll work on one developer's machine, not another person's, because of the sort of ordering of what versions each person's using. And then the discontinued libraries. So now I'm going to talk about an obscure bug. And if you've hit this, this slide will make sense. And if you have not, hopefully this will explain it. This was a bug in core async, where if you used a try-catch block inside of a core agent or a core async Go loop and it hit that exception, it would then generate an infinite loop. It would just keep putting the data back in and reprocessing it, and it was very unobvious what was going on here. This is very rare, but you can see how long it was in the code for. I mean, almost a year. And so sometimes when those bugs exist, I don't know if it just wasn't hitting everyone else as bad as it was hitting us, but it was a very unobvious bug too. This is like one of those things where you would think try catch works perfectly fine. And in fact, the workaround is to like catch a run, I can't remember. Instead of an exception, you catch like a runtime error or something like that. Some other thing. I mean, there was a workaround, but you'd have to realize that was your problem and not something in your own code. So when you get used to where everything's so stable, then when bugs happen, you look at your own code and you stop looking at things like the core Clojure library. And it's still sort of maturing in that sense. I actually found out yesterday that Kevin Downey fixed this bug, so thank you, Kevin. I thought I saw you. Much appreciated. It was a big deal. All right. And so this is team. This is about our staffing, what we loved, what we didn't. We found that people who have Clojure experience sort of means they're a self-learner, which is something that is key to who we hire. It's not just Clojure, though. It's a lot of like other languages that wouldn't be mainstream. It's just one of those indicators to us that they're someone who is self-learned, unless their previous job made them learn Clojure, which some of our team will be those people. But they're also great. We've also found that they're amazingly productive on a fewer number of people, whether that's because of Clojure itself or that they're these self-learner types. We can do a lot more on a much smaller dev team than I've seen in a lot of places because of that. I think that Clojure and all of the JVM libraries, et cetera, kind of give you this much bigger lever to work with so that you can focus on just your problems and get much more done. And then it also forces this much higher level of conceptualization around sort of functional programming, things that are, I guess you're not so overwhelmed in the intricate details because there's only sequences and hashes or maps, whichever one you want to call it. And so it allows you to sort of think more generally, more broadly around these concepts. I mean, it's almost like a sort of mathematical type thing where you're trying to come up with equations that would work at this sort of very high level, and that just allows you to come up with some really nice, elegant solutions. We learned teaching Clojure can be hard, which is just a thing that we've learned. Don't learn Emacs and Clojure at the same time. That the sort of path from people who didn't know Clojure is at first they're like, oh, that looks kind of cool. They watch the Rich Hickey talk and they're like, that just all makes sense to me. Then they absolutely hate it. Then they're a little bit confused by it, and then they sort of love it. So expect that if you're bringing new people on your team. And we've also learned it's not for everyone. We've actually had software consultants that ended up not charging us because they were just like, yeah, we're not going to be able to do this after putting substantial time in. It just didn't jive with how their sort of mental models worked. And so that's also a thing to sort of be aware of. And what I guess I kind of hate is that it's hard to find experienced people, and experienced people are expensive. So that's either bad news or good news for you. It just depends, which side of the equation you're on. But that's just a thing that we have to deal with until the community gets larger. All right. So sort of a summary for it is that it's been an overall win, though. I mean, we're not unhappy with our choice. I think that even our approach to the problem space that we're solving was definitely influenced by some of these higher level Clojure concepts that you are sort of forced to learn in order to really grasp Clojure. So it's been a great experience for us, and growing our team will be tough. both because people are hard to find and expensive. So this is some of the libraries that we're using. So I don't know if people ever thanked any of these libraries. I just kind of went through, got a bunch of these things out of our source code so that I made sure that we were thanking sort of the base of things that we're built on. I mean, the community is really amazing. There are lots of things in here that we use in big ways, small ways, etc. And we couldn't build what we did if you guys or these people didn't build what they did. And so they all rock.